Hello everybody and welcome back to another video, and in this video I will go over problem toss a coin to your graph from Codeforces round 791. That was a Div2. So let's get started. So what have we been given the problem? So we have been defined a directed graph. So we have been given a directed graph in the problem that is being defined using three parameters. First parameter is n, that is the number of vertices. Second parameter is m, that is the number of edges. And third parameter is a, where ai defines the cost or weight of vertex I. So if I have to draw a graph, it will look something like this. Let's say weight of this node is 5, weight of this node is equal to 7, 6, 5, 4, 10, 20. Also we have been defined a cost of a path. Cost of a path. What is the cost of a path? Cost of the path is the maximum weight of vertex included in it. So if I define, let's say if I define a path here, let's say I define the path 5, 10 and 20, then the maximum weight on it is 20. So cost of this path is equal to 20. So if I define the path 5, 10 and 20, the maximum weight here is 20. So cost of this path is equal to cost of this path is equal to 20. Similarly, if I define path, let's say 5, 7, 6, 5, 4, then the maximum weight on this path is 7. So cost of this path is equal to 7, right? So that is the basic definition that we have been given the problem. Also we have been given an integer k. We have been given an integer k. So let me redraw my graph here. This is 5, 10, 20, 7, 6, 5, 4. Also we have been given an integer k. We have to tell the minimum cost of a path with k vertices. So I have already defined the cost of a path above, you can see, right? So we have to tell the minimum cost of a path that contains k vertices. So for example, let's say k is equal to 3 in this case, then one possible path is 5, 10 and 20, but the cost of this path is equal to 20. But it is obviously better to choose the path 6, 5 and 4. It is obviously better to choose the path 6, 5, 4, because the minimum weight on this path is equal to 6. Minimum cost of this path is equal to 6, right? So the answer in this case for k equal to 3, will be my path 6, 5 and 4 whose cost is equal to 6. So we have been given a graph and we have been given a k, and we have to find the minimum cost of a path with k vertices. So that is basically the definition of the problem. So let's see how we can achieve this. As we have to find, the minimum weight, right? Minimum cost of a path. So obviously we have to minimize something, right? We have to minimize something. So there are very few algos that we use when we have to minimize or maximize something, and a very trivial of those algos is binary search. Very trivial algo to maximize or minimize something is binary search. So let's try and see if we can apply binary search on this, right? So let's try and draw a graph for this. Let's say this is my x-axis, right? It represents the cost of the path, and this is my y-axis. It will tell me if it's possible to have k vertex path with cost less than equal to x. So if I draw a graph here, this will be my answer, right? My minimum cost of k length path, and this will be my answer, and here it will be my maximum of AI. Obviously it will never be possible to have a path whose cost is less than the minimum cost, so answer here is no. And obviously if there is a path with minimum cost on the left, it is always possible to have a path less than this cost, right? So it is obviously possible to break it into two different quadrants, right? No and yes. So we can easily binary search for this minimum cost. We can easily binary search for this minimum cost here. So how can we we can do binary search, but how can we tell if it is possible to have a path less than or equal to x? What I mean to say is, let's say I have been given a graph, something like this. I have been given some graph. This is an example graph. How can you tell if it is possible to have a if this graph has a k length path, if this is a k length path where every vertex is less than or equal to x, where the cost of the path is less than or equal to x. So obviously if the cost of the path is less than or equal to x, then every node on this path has cost less than or equal to x, has cost less than or equal to x. So for example, if I have let's say this node has cost greater than x, let's say this cost has this node has cost greater than x, then these nodes are useless to me now. These nodes won't help me, so I will block these nodes. And then I will try to find if there is a path of length k in my left graph. So now all these nodes are less than x. Now all these nodes left are less than x. Now in the new left graph, I will try to find if there is a path of length k. So here you can easily see that there is a path of length 3 here, right? So if my k is equal to 3, the answer here will be yes. But here if k is equal to 4 here, then there is no path that is of length 4. So then the answer here will be no, right? So now you are able to define your is possible function also. So now you can run your binary search. So now your low will be obviously your weight here, the minimum weight here will be 1. So your low will be 1, and your high will be maximum of AI. In the question that is 1 e the power 9, right? I guess, and let's check. Right, so maximum of AI is 1 e the power 9. So you can now run a binary search on this. While low is less than or equal to high, your current cost will be mid, right? Your current cost will be mid. Mid is equal to low plus high over 2. If it's possible to have path with weight less than equal to x, less than equal to mid, then I will update my high is equal to mid minus 1. Otherwise my low is equal to mid plus 1. So this is basically your binary search, and now your main effort will go into checking if it is possible to have a path where weight is less than or equal to mid. Now you have to do this step. If it's possible to have a path whose weight is less than or equal to mid, whose weight is less than or equal to mid. So obviously you have a graph here, right? Something like this, whatever. So obviously all the nodes where the weight is greater than mid, they are useless to us. So we will block them, and we will block them. And then we will check if we have a path. That is greater than or equal to k in length. How can we check that? So for that we can use a DP, right? It is a very well-known problem. You can Google it online. I think you will also find it. Maximum length path in a directed graph. Yeah, I think the longest path in a directed graph. Yeah, you will find something like this. So it is also a very well-known problem. You can also look for it online if you want to, but I will still give you an idea here. So I will define a DP of node. It will define maximum length path starting from this node, So for example, if here I have something like this, then the DP value of this node will be equal to 3. So how can I make transitions here? So if let's say a node has, many children, right? Something like this. So DP of this node will be equal to 4. DP of this node will be equal to 3. Then if they have a parent, let me draw directed edges here. Then if they have a parent, then DP of this parent will be equal to 1 plus maximum of DP of these children. So I can write a DP of its children. So that is how you can make transitions for this. So in this way you can find the maximum length path in a directed graph. And obviously we have blocked these nodes, right? So we will not consider these nodes when we are working on our graph. So we will ignore these nodes. And another case can be when we have a cycle in the graph, because it may be possible that we have a cycle. So you also need to check for a cycle in a directed acyclic graph. It is also a very well-known algorithm. You can use some kind of stack to use it. I kept a vector as a map. And so how do you find cycle in a directed acyclic graph? So if I'm running a DFS, while I am running a DFS, if I am in, let's say if this is node 1, this is node 2, so I kept a map, like I kept a vector, but it acted kind of like a map. So I kept a map and I named it DFS stack. So when I'm running a DFS, if I'm currently running a DFS in node 1, so I will insert my node 1 into my map. So I will set my DFS stack of 1 equal to 1. I came into node 2. I will then set node 2 DFS stack equal to 1. So it means that currently these nodes are in my DFS stack, right? So if I am visiting some nodes, and if I hit some node that is currently activated in my DFS stack, then it means that my graph has a cycle, right? And when I come back from my DFS, I reset these. So I will, if I have visited all my children in node 2, then I will come back from my DFS and I will set DFS stack of node 2 equal to back to 0. So that is how we find cycles in a directed acyclic graph. So this was a accumulation of 2 to 3 algos, right? So I will once again summarize what happened here. So first step will be step 1, binary search over the minimum possible cost. Where low will be equal to your 1 and high will be equal to 1 e to the power 9, and your current cost will be net. Then step 2, check if there exists a k-length path with weight less than equal to mid. How can we do this? So to do this, that is your step 3. Block all nodes with weight. Block all nodes. Block all nodes with weight greater than mid, because they are useless to us. Because they are useless for paths with weight less than equal to mid. Right. Step 4, find maximum length. Not find maximum length, find if there exists a path with length greater than equal to k in this new graph using DP. And what is your DP here? DP of I will be maximum path length starting from node I. And what will be your transitions? Your transition will be DP of parent is equal to 1 plus maximum of DP of all its children of this parent. That is how you will find, right? And then you can check if there exists a node. Then check if there is a node with DP of node greater than or equal to k. Also another step will be also check for cycles. In case of cycles, set DP of node equal to infinite. And how can you check for cycles? To check for cycles, you can look for algos online, or you can like kind of keep a map or a DFS stack. Keep a DFS stack, and that is your basically the whole approach to this problem. So if you want to see my code for this, here's my code. Here's my graph. This is my cost matrix, right? Then I have input my graph here. Here's my binary search. See if I have to comment here. Binary searching over minimum cost. Then I have checked if it is possible to have a then check if it's possible to have k length path with cost less than equal to x, less than equal to mid here, sorry. And to check it, I have made a function. So let's see what I have in the function here. So here, if it's possible, I have kept three vectors. First is my visited, the second is my DP, and third is my DFS stack vector. So if the current node is not visited and cost is less than equal to mid, so don't run this for blocked nodes. Right? Where cost is greater than mid. So I have defined here cost of I is less than equal to mid. I will run my DFS and DFS to find my maximum length path here. So here is my DFS. If we don't know the maximum, right, you already know what my DP means, so I will still write here DP of I is equal to maximum length path starting from current node I. So if I don't know DP of current, so sorry, if I already know DP of current, then I will just return it. Otherwise, I will have to find it. And when I'm running a DFS on a node, I will set it stack to 1. Like currently, it is in the stack, and it is also being visited. So I will set visited of this node equal to 1. So here, currently this node is in DFS stack. This is to check for cycles. Visited of current. This is to prevent multiple visits, right? I can also write if visited of current here and then just return DP of current, but like there are many ways to do this, right? You can do it however you want to here in this part. So for every child, right, for every child in adjacent of current, if cost of child is less than equal to mid, right? If cost of child is greater than mid, then this node is blocked. Ignore it. Otherwise, if cost of child is less than equal to mid, I will go into it. And if DFS stack, if the child is already in DFS stack, that means we have found a cycle here, right? Then that means that we have found a cycle. Then I will set my DP of current equal to infinity. Right? Path has infinite length. Then I can just break out. Otherwise, this is my DP here, my DP transition. My DP of parent is equal to 1 plus max of DP of for its every child. Child. Then when I'm done with all its children, I will pop it out of DFS stack. So I will set DFS stack of this node equal to 0. Then I will just return the path length of my current node, that is DP of current. So if I will try to sum with this, Yeah, so it got accepted. Yeah, so that was it for this video, and if you guys have a doubt, do let me know in the comments and I will be happy to help you out. Bye-bye. So if you guys don't know, Newton School is currently offering a 6-month full stack development course, right? It is totally based on pay after placement model, so आपको कुछ पे नहीं करना है upfront, right? There is zero hidden fees, there is zero upfront fee, कुछ पे नहीं करना है आपको. And they will get you placed into top MNCs like Google, Flipkart, Zomato, etc. with a minimum package of rupees 5 lakhs. So they are guaranteeing that they will get you a minimum package of rupees 5 lakh, but that is the minimum, of course, right? The average package is around rupees 7 lakhs and the highest is rupees 26 lakhs, right? And the placement rate is over 90%. Also, जो इनके mentors हैं, all their mentors are from FANG, right? From Goldman Sachs, from Amazon, from Flipkart, Google, etc. So you can be assured कि जो भी mentorship है, you are getting top mentorship. The quality of the course is top notch, right? Also, अगर आपको थोड़ा मतलब आप थोड़ी hesitant हो कि मेरे को coding नहीं आती है, how will I cope up? You don't need to worry. You just need to sign up for an aptitude test. अगर आप उसमें अच्छा करते हो, you will be signed up for the course, right? And ये 6 months लंबा course है, right? So you don't need to worry. They will teach you from scratch. So you can still cope up. अगर आपको कुछ भी नहीं आता है, if you don't know coding, they'll teach you from scratch, right? And the course is very beginner friendly. So if you guys are looking for a job, this is definitely a head start that you should aim for, and I will highly recommend this if you are looking for a job in the tech field, right, or a similar area, right? So do sign up for this. The link will be down below, and let me know if you guys have doubt about the video as well. And do let me know the questions or the problems that you want to see solutions for, or some general improvement tips, and I will be happy to cover them as well.